Hello everyone, welcome to Oracle CloudWorld. My name is Ali Mukadam, and today's session is a deep dive on OKE deployment. OKE is Oracle's managed Kubernetes offering on OCI, and today's session we're going to look at how to use them with other services on OCI, in particular infrastructure services, database, security, and developer services. And finally, we are going to take a look at some popular and useful add-ons for your Kubernetes deployment. So let's start with infrastructure services. Typically, when you deploy Kubernetes, there's a number of infrastructure decisions, in particular those related to networking. And that means you need to take a look at your virtual cloud network. Some of the design decisions that you need to make is how are your worker nodes going to be deployed. Um, so in order, you need to have a number of subnets for this, so that you can separate all the various components of OKE. So you would need to have a subnet for worker nodes, one for the load balancer, and one for the control endpoint. Now, each of them, you can have different type of access. Each of them can be public or private, and any number of combination depending on your and your requirements, whether your application or your security requirements. Based on each of these, your the access, you need to have different. You need to use different gateways as well, whether it's the internet gateway, the NAT gateway, the service gateway. And in case you're going to be using multiple VCN or resources from multiple cloud networks, you might need to use the dynamic routing gateway or local peering gateway as well. Um, the use of the gateway and the visibility of your subnet, you can control these by setting the routing table. And if you, for example, your worker nodes are private, then you need to create your routing rules need to be able to route to the NAT gateway. Conversely, if your load balancer is public, then the corresponding load balance subnet need to route to the internet gateway. So these are some of the of the uh, design choices you need to make, and they are all kind of interrelated. Likewise, the various components of your Kubernetes deployment, such as your load balancer or your worker node, in order for them to work effectively, you need to set some security rules. In OCI, you can do so using security list or using network security group. Uh, until recently, we've had only security lists, but NSG's the or network security group is the way recommended going forward. That being said, if you've already have cluster deployed with security lists, you don't need to to rip them out in favor of an NSG, because what we do is effectively a union of the security rules defined in security lists or the NSG. Um, Similarly, some users like to choose what kind of access they want to give to their control plane. But it is preferable that your control plane is private, but in some cases, you might want to make that publicly available. Likewise, it is recommended that your worker nodes are private and you expose your application through a public load balance or even a private one. So let's take a look at the diagram to simplify, to illustrate all of this. So on the left here, this is where your worker nodes are placed, and they are typically this is a subnet dedicated to the worker nodes. The control plane, if you have used OKE before, is actually you don't have access to the control plane because this runs in Oracle's tenancy. However, in order to get the worker nodes and the control plane to interact, and especially if you need to have some kind of administrative API level access to the API server, then what you need to do is basically make the control plane available in a subnet within VCN. It is preferable that you set it up in a different subnet from the worker node, and you govern the access between them using security lists or NSGs. Your applications will be running on the worker nodes, and depending on where you're going to access or how you're going to access your application, whether privately through a private load balancer or publicly through a public load balancer, you can expose those applications accordingly. Similarly, you can also use the public load balance subnet to place something like the OCI API gateway in here, especially if your application is API driven. If your application is going to be using some kind of a OCI services like the autonomous database or like OCI streaming, or if you're going to be using the container registry to store your images, what OCI does is it runs all these services inside the Oracle Services Network. And in order to access them, rather than the worker node going out on the internet and accessing these services, you can do so using the service gateway. All of these design choices, we have scripted them on the Oracle Terraform module for OKE. You can access this on the URL below here. And there are a few more deployment options that are available with the OKE module. Now, once your application is deployed, what you need to decide is how your users are going to access it. And typically, this is done through a load balancer. OCI allows you to choose between making your load balancer private, public, or private. By default, it's public, but you can override this behavior and set it to private. Similarly, you can choose between the HTTP load balancer or network load balancer. And again, by default, it's the HTTP load balancer that is created, and this is partly due to for historical reasons, because we had the HTTP load balancer right from the beginning. Overriding these behaviors can be like whether your load balancer is going to be public or private, or whether you're going to be using the HTTP or network load balancer. You can do so using the Cloud Controller Manager. And the Cloud Controller Manager also allows you to control the security list and the NSGs. Like, for example, you can attach some specific NSGs to your load balancer, and you can also get the Cloud Controller Manager to set up the right security rules. What happens in the background is that the cloud, when you deployed a service of type load balancer, under the hood, a service of type node port is created. And what the CCM does is that between the OCI load balancer and the worker node, it set up the worker node as backend services for the load balancer, and then depending on what port number has been assigned to those services, it configures the security list as well. You can choose not to do that. You can turn this behavior off as well. And what you can further do is that you can choose between the type of load balancer, between dynamic and flexible. The dynamic load balancers, they come in three buckets. Those in the shape of 100 megabits per second, 400, and 8,000. Whereas flexible, you can be a lot more granular, and is the recommended way going forward. You also have the option of where you're going to use SSL, where you're going to terminate SSL, or whether you're just going to pass it through. So all these behaviors, like I mentioned, can be controlled through CCM using annotations. The annotations come in 3 buckets. The first one is the service.beta kubernetes.io. These are from the very early days of OKE, and they are used for load balancer, for the HTTP load balancer only. For example, you want to set the override the visibility of the load balancer to private. You would be using there's an annotation there, or and to set it to private, and you would use the annotation from this bucket. More recent annotation and enhancement, we put it in this OCI.oraclecloud.com API, and they allow you to control the load balancer policy. They allow you to control different other behaviors as well. So and all of these are available on both on GitHub, where the CCM is being developed, as well as in OCI documentation. For the network load balancer, there's a third set of annotation available, and it's meant strictly to govern how the NLB will be behaving. I talk a little bit more, a lot more about the load balancer in the session 3579, and this session is a lot more focused around the using ingress controllers and some subtle behaviors around load balancers and what to watch out for, the annotations, the security lists, etc. All right. Now, once you have created your load balancer, your application is publicly available. You want your users to be able to access it easily, and that generally means some kind of a DNS integration. You can integrate integrate this with any DNS, but for the purpose of this session, we're going to talk about OCI DNS. To integrate it with DNS, you can do so manually. Where if you have your zone is being managed in the OCI DNS, basically you add an A record for an IPv4, either via the CLI, the SDK, the OCI console, or even using Terraform. Alternatively, what you can also do is you can automate this using a project called External DNS. External DNS is a Kubernetes sub-level project, and it allows the integration between Kubernetes and DNS providers. The way it works is that when you create your ingresses and you set ingress rules, external DNS detects these, and then it basically updates your preferred DNS provider. In this case, OCI DNS. Note that external DNS, regardless of where they are running, you can update any of the supported DNS. Now, for the purpose of OCI DNS, it requires a user principal created a secret that allows external DNS to authenticate with the API to create the records, basically. I talk a lot more about this in my blog, so you can follow the link here. Now, a more secure option is to use an instance principal. So instance principal is a mechanism in OCI where you basically designate some compute instances to be able to carry out certain restricted API operations, and you can restrict which one you want them to be able to do. In this case, it's updating OCI DNS. The advantage of using instance principal is that it does not require you to configure the keys, your API keys in a secret, and you don't need to put the keys anywhere for that matter. We have a pull request open on the external DNS for the last couple of years. Unfortunately, it has not been merged. Please help us by voting so we can get it merged, and this can improve the security posture of your Kubernetes, especially when you're integrating with OCI DNS. Now, once you have your application is public, you have defined your DNS. What you can further do is you can use OCI's traffic steering to define your certain load balancer policies, for example. As the diagram illustrates here, I have two Kubernetes clusters, one in Mumbai and one in Hyderabad. I've exposed them with publicly using load balancers. Now, what I want to do is I want to create some kind of a load balancer policy. Basically, some traffic goes to Mumbai or some traffic goes to Hyderabad. And the way to do that is, first of all, to create a health check. The health check points to create a number of targets. The targets in this case are your load balancers, where and the DNS associated with them. These health checks they run from different vantage points, and what we do in these vantage points is that they don't run within OCI; they run external to OCI, typically in other cloud providers like AWS, Azure, or GCP. And you can specify the protocols, the port number, and the path as well. Once the health check are defined, then you set up your traffic steering policy. You can either do a load balancer or failover, or you can even say if users from a certain particular region or a certain particular IP addresses, I want to direct them to this Mumbai cluster, for example, or users from particular countries, I want to direct them to the Hyderabad cluster, for example. So depending on your application, depending on your high availability needs, you can use traffic steering to direct your traffic as well. Another scenario to use traffic steering is that, especially if let's say you can use that for DR purposes. Let's say you've got to do maintenance on your Mumbai cluster. You need to bring it down, for example, maybe for upgrade purposes or some other reasons. You can do so, and then what will happen is that the health check will detect that the traffic is it's failing, and then it will remove the Mumbai cluster from its answer pool, and then all traffic will then be directed to the Hyderabad cluster instead. Traffic steering is very useful, especially if you've got multi-cluster. At the same time, it's not limited for your cluster. It's not required for your cluster to be on OCI. Your cluster can be on other cloud providers, and it can also be on premise as well. Now, some users require some kind of connectivity to OCI, mainly for two purposes. One for administrative purposes, others for users. Typically, most users start with a VPN. There's the OCI VPN available, but other users are also using libswan. WireGuard is getting attention now, or others are using commercial VPN available on the OCI marketplace. Very quickly, though, what users do is they upgrade VPN to Fast Connect, and then do some kind of a hub and spoke deployment. I want to point out that the OCI VPN, that service is free, and it doesn't require you to run a compute instance, as opposed to if you were to run your own open source or commercial software. So that's that's a choice you will have to make. Now let's look at how this is going to work. So direct connectivity via VPN. So what you can do is from your on-premise environment, or router, or gateway, you establish a VPN connection to the OCI VPN. The advantage of this is that you can limit who can the what kind of which clusters users can access. This can be for administrative purpose or and the application as well. That being said, if you have a large number of clusters, having a one-to-one VPN connection between each VCN is quite tedious to set up. Or if you have some kind of like a part of your data might reside on premise, or you need to migrate, or your workers need to create data directly from on premise. VPN may not be sufficient, depending on the bandwidth. So what users tend to do is they tend to graduate to Fast Connect. Now, Fast Connect are available in ports of 1 gig and 10 gig as well. Depending on your bandwidth and application needs, so you can choose accordingly. Now, if you are going to, it's not what Fast Connect can be expensive if you're going to do this for each of your VCN, each of your clusters. So what users tend to do is to go by a hub and spoke model instead. So instead of landing directly at the VCN where your OK clusters are running, what users tend to do is to land at a kind of a intermediary VCN instead. So this is where the Fast Connect land, and doing so gives you the additional advantage of placing a firewall, like the OCI firewall in between. In this way, you can be a bit more prescriptive around who can access the application, or who can access the control plane, whether it's admin access or user access. You can be a bit more prescriptive. In doing so, you can limit your need for Fast Connect maybe to just one connection if necessary. Now, these are for networking requirements. Now, let's look at computing requirements. These are mainly for worker nodes, and there are a few things to think about. One is what kind of architecture you're going to be, CPU architecture especially, you're going to be using for your worker nodes. The shape of computer that's available is x86. There are ARM CPUs available, and GPUs were available as well. These come available in the shape of VM, in the shape of bare metal, and GPU nodes as well. The reason these are available is that you can be more selective in terms of what or where you're going to be running your application. And you can also create some kind of specialized workload, particularly if you're going to be running things like, let's say, clusters autoscaler. You don't need a large node pool to run your cluster autoscaler. At the same time, you don't want it to be managed by the cluster autoscaler software. Likewise, if you're going to be running, exposing your application publicly, usually users do so using an ingress controller, and you can do some additional tuning with the TCP BBR algorithm that's now available in the Linux kernel. Other parameters to configure around your compute are time zone and boot volume. Time zone, you can set um, this according to where you're located or where your SREs are going to be located. Um, the, the Whereas the boot volume allows you to set how big the boot volume is going to be, uh, especially if you've got some large images. There are customers who've got images which are very large, and allowing the configuration of the boot volume. Make sure that when you deploy your application, the download of these images are successful, and therefore you're able to allow you're able to start your application successfully. Finally, one additional parameter that is available for you to configure for compute is the type of images you can use. Until recently, you had basically two choices. One, do you want to use the platform image? Another one to use a custom image. The platform image basically requires you to create to use the one from the compute service. However, what happens is that all the OKE software, like the kubelet, etc., they need to be installed every time. The custom allows you to do maybe install additional things that you require yourself, either by organization policy and whatnot. Recently, however, what we have done is we have made OKE optimized images to be available. And the advantage of using the OKE images is that they come preloaded with the Kubernetes software. And once they boot, all they need to do is your worker nodes, they just need to join the existing cluster. The graph here shows you the time taken to start from the moment a worker node has been created to the time it becomes available, and this is for a 2 CPU, and you can see that the line in red, this is for the platform images, whereas the one further below, these are various trials for the OK images. To put this in perspective, this is roughly the percentage improvement you can kind of expect is around 15 to 25%. And on the left here, the graph on the left here shows you the performance, the percentage improvement. On the x-axis, that's the size of your node pool, and we keep the CPU and the memory constant in all of them. So it's pretty significant. And you can use the OK image to your advantage, especially if you need to scale out during peak time. Now, for block storage, the OCI BV is now the default storage class for clusters created after the 1.23 release. If you've got clusters that have been that you created earlier and you're upgrading, they would still use the OCI storage class. However, you can change the default storage class to OCI BV to use the new one. When you set up a PVC to use the block storage, the minimum and default storage size is 50 gigabytes. Now, and you can use PVC to request for a higher initial storage. Using the OCI BV, you can set an additional parameter to allow volume expansion. And this is using the new CSI driver. And doing so, you don't need to destroy your PVCs and recreate a new one. So this allows you to do the expansion. Further, what you can do is that you can monitor its usage with Prometheus. So this is done through Kubernetes. So if you've got Prometheus deployed in your cluster, the metrics are going to be captured, and you can monitor the size of or usage of your block storage. By default, the block volume set a VPU of 10 for balance. VPU stands for volume performance unit, and this is a setting for OCI block volume. Basically, they govern how much IOPS you can get out of your block volumes. There's one lower than this, which is available, and then there are a few higher. Obviously, higher VPUs they give you more IOPS, but also at a higher cost. So if you've got applications that require high IO, and you can create a new storage class and to set the VPU accordingly. The link below shows you will bring you to the VPU values and what kind of IOPS you can obtain from each of these. Now, the similar to the block storage, we have a new CSI driver for the file storage service. Because of this, we don't need to define a new storage class to use the file storage anymore. You configure it directly via the PV, and you can even use the encryption in transit feature for file storage service. Note, however, that if you're going to use the encryption in transit, it requires the OCI FSS Utilis package to be installed on all the worker nodes, and you can do so using Cloud Init. And you also need to define the ingress and egress rules on your NSG or your security list. And then finally, you can, when you define the PVC, you can set the mount points to your file storage instance. That's a little bit of a overview around infrastructure services. Now, let's look at using database services. As you know, we have on OCI, we have the Oracle database, and we also have the Oracle Autonomous Database Service. How they are, let's look at how, first of all, they run and how we can eventually access them in the context of OKE. The Oracle Database Service, it runs on a VM or bare metal inside a VCM, which means that you have, as long as you have connectivity, you have a direct access to the VM or the server running the database. Whereas the autonomous database, it runs as a service. You don't have VM or SSH access to where the database is running. Both of them, in order to access them, you need to configure security lists or NSGs. And now, for the Oracle database, if the same VCN is used as OKE, so imagine you've got your OKE cluster running in a VCN, and you have deployed the database in the same VCN, you don't need to configure any further routing. Whereas if a different VCN is used, then you need to configure and add an additional routing rule via a DRG. For the autonomous database, this is typically accessed through a service gateway. So you need to make sure that you have a routing rule that specifies routing through the service gateway. That being said, the autonomous database, there are two ways to access it. One is the traditional way through the service gateway. Another one is through what we call the private endpoint, and this is kind of similar to what we do for the OK control point. the way to think of the private endpoint is that imagine that you are running this as a VM, the autonomous service as a VM. So therefore, it has a presence on your VCN, except you still don't have access SSH access to where the database is running. In this case, the same rule as your VCN, either same or different, the same rules apply if you're going to be using the private endpoint. In terms of provisioning, you can provision using the OCI console, using the CLI, using the Terraform, using the SDK. Um, Whereas for the autonomous database, in addition to these, you can also provision them through the OCI service operator. The OCI service operator is an open source Kubernetes operator that uh, Oracle has developed, and you deploy them on your Kubernetes cluster. Bear in mind that um, you can also use the OCI service operator on any other Kubernetes cluster as long as you have access to the OCI service. What the OCI service operator does is that through it you give the instruction to provision the autonomous database, for example. Um, when you're using the Oracle database service, you need to retrieve the wallet and store the wallet data in a Kubernetes secret manually. Whereas this operation is done automatically for you during binding if you have provisioned this using the autonomous database using the service operator. Now, if you have uh, if you have provisioned your autonomous database not through Terraform or through the CLI, the SDK, then you need to take the same manual step for the creation of this and storing of the wallet data in a secret. Similarly, for the MySQL database service, you can provision this manually. That is through Terraform, through the console, or through the SDK CLI, or you can use the service operator as well. And you can use secrets to store the connection information. And similar to the autonomous database, the service operator for Kubernetes, it creates the connection information automatically. All you need to do is just start retrieving in this case, you just need to start retrieving the connection information and start using it in your application. Note that some applications still use MySQL's traditional method to authenticate. Usually, and if you cannot change the code, for example, an application like Drupal, you cannot. You're waiting on when they are going to update uh, the authentication mechanism. If you cannot change that code, what you can do is that you can modify the authentication mechanism like so. So you create a user, you set it to be identified with MySQL native password. I wanted to point out the MySQL shell. It's truly amazing, and there are a number of modes that are available. It's not just a SQL mode, but there's also a JavaScript mode, and there's also Python mode, depending on your application that you're going to be deploying on your OKE clusters. This can help you tremendously in terms of interacting with your data. Um, Recently, we GA'd the OpenSearch service. So the OpenSearch service is based on the OpenSearch open source project. Sorry, and what you can do is that you can use it to ship for a number of scenarios, mainly to ship your logs to the OpenSearch service using either FluentD or FluentB. But you can also imagine using the OpenSearch as a traditional search engine for your application, especially if you've got data to index and you want to give your users the ability to search. And in this case, the Open Search service saves you the trouble of having to implement and manage your own search clusters. You can use, if you're looking more around log analytics, there are open search dashboards. And in order to access them today, you need some kind of private connectivity using either the OCI Bastion service or a VPN or something similar. The open search dashboard, the service, they give you more or less the same experience as the Elk stack. And if you're going to be using Verrazano, which we are going to talk about in a few slides, Verrazano is an enterprise container platform. It allows you to ship your logs to an external open search instance. In this case, the open search service. Now, let's talk about security services. So you, after deploying your application, you want to ensure that it's secure. One of the ways you can secure your Kubernetes, your application running on Kubernetes, is to use the web application firewall. And there are two ways you can deploy them. One is at the edge, and essentially what you are instructing your load balancers to only accept requests originating from the edge subnets of WAF. Requests originating directly from elsewhere are going to be rejected. And what you can further do then is that in the WAF, you can set certain policies about to protect your application from things like, for example, SQL injection attacks. Now, WAF does not exist only at the edge. It can also you can also deploy it directly at the load balancer, especially if your application you're going to be running your application and accessing them privately. In this case, you don't need to use the WAF at the edge option. What you only need to do is define your policies that will protect your application. There's also, in terms of security service, there's also the vulnerability scanning service, and this is you can use that if you're using the container registry. OCI has a container registry in every region that is deployed, and the vulnerability scanning allows you to scan your images for CVEs. And you do so by adding a scanner to the repository. Any images pushed to the repo will be scanned. When new CVEs are added to the CV database, the vulnerability scanning service automatically scans the images with only those repositories that have scanning enabled. And the scanning results give you the following results. One, the name issue is the name given to the vulnerability. What kind of risk level? And these are classed into minor, low, medium, and high. And then a description of the vulnerability. For the purpose of encryption and using confidential information, there's the OCI Vault service, and the OCI Vault service has two two features. One is the KMS or key management service, and then the other one is the secrets. KMS, what you would use them to do is mainly for encryption purposes. So you would use it to encrypt OKEs underlying etcd. Although we don't, because OK is a service, there's no direct access to the etcd itself. Nevertheless, you can still use your own keys to encrypt the underlying etcd. And you can use the keys to encrypt your block volume, especially if you've got data, or to encrypt the FSS in transit and at rest. Further, what you can use the KMS is to sign images that are so that when OK do a deployment, you can restrict the deployment to images signed with those keys only. So you would store these keys in KMS, and then depending on how you're building your images, you can sign these images with those keys, you and then store it in a container registry. This can be excuse me, this can be the OCI container registry, or an external container registry as well. Secrets, on the other hand, it helps you to store confidential information such as password, keys, or if you're using the autonomous database like the wallet information. And today you would retrieve them with the external secrets operator. What we are doing is working with an implementation of the secret store using the secret store CSI driver. So this will give you a more native experience, if you will, of extracting secrets from secret involved. Finally, the Bastion service allows you access to private resources such as your worker nodes. So if you need to troubleshoot some worker nodes and see what's going on, the Bastion service allows you to create an SSH tunnel. If your control plane endpoints are private and you want to interact with them occasionally, you can do so using the Bastion service. The OpenSearch, especially the dashboard, they need some kind of connectivity. Bastion is one of the ways to access the OpenSearch, and also the various databases. Let's now look at some of the developer services. So one of the first one is container registry. So it's an OCI managed open container initiative compliant registry. You can have up to 500 repositories where you can store 500 gig by default. You can increase this on request, and each repository can store up to 100,000 images. The container registry is Docker V2 compliant, and it's private by default, which means you require authentication. Typically, this consists of an OCI account, and you need to use an auth token as password. The auth token will be stored in a secret, and when you deploy containers that you're going to be pulling from the container registry, in this case, you need to specify the secret in the image pool secrets, and you must ensure that your secret is defined as in the same namespace as the deployment. The advantage of the container registry is that it's region located with the OKE, so this massively reduces the latency to download your container images compared to Docker Hub or some external registries that you may have been using until now. And it supports private access, which means that the transport of the container images is secure, and you don't incur egress charges either. There's also an API gateway. So like the load balancer, it can be public or private, and it largely depends on whom you're exposing the application to. If your application is API driven, you can use the API gateway, and there's a number of authentication mechanisms available for you to use. Similarly, streaming is a Kafka API compatible service. So if your application is using Kafka to some extent, you can switch your Kafka dependent application to OCI streaming. All you need to do is change your endpoint to point to the OCI streaming one, probably change your authentication method as well. And then potentially you might need to change your library version. I had a customer who was using an older version of Spring Boot, and that older version of Spring Boot was using an old library, all they had to do was update their library version, excuse me, in their pom.xml, their Maven pom, and they were up and running with OCI streaming. So change these three parameters. Don't change your application code. You can stop worrying about managing your Kafka clusters going forward. Like a lot of other OCI services, the streaming service can be public or private. You can access it publicly through the service gateway, or you can access it as a private endpoint as well. In terms of interacting with your cluster, there's Cloud Shell. So Cloud Shell is an in-browser terminal experience through the OCI console. It comes with OCI CLI and the kube control pre-installed. You retrieve the config. And very recently, what we've done is we've added private network access, and this is particularly useful is if your control plane you've deployed them in private mode. So what you do is you would select the private network setup, choose the VCN, and then choose the subnet where your control plane is running. In doing so, you can interact with the Kube API. Note, however, that Cloud Shell does not. If you're going to be using kube control port forwarding, this is not possible using Cloud Shell. In this case, you need to use some kind of a bastion host or service, or use VPN. Similarly, there's a DevOps service. It has an integrated code repository, which can mirror or monitor external repositories like GitHub, Bitbucket, or GitLab. And the DevOps service also includes a CI/CD capability. So it's a free service. There's pipelining. You can put scripting, many deployment strategies, Canary, Blue, Green. You can deploy Helm chart. All of this is to enable GitOps, basically, and it now supports, like the Cloud Shell, it supports private clusters as well. More than just OKE, however, if your application consists not just of OKE, but also other related targets, like, for example, functions, VM, Bevel, or instance pool. You can use the DevOps service as part of a integrated whole for your pipeline. Lastly, when you're using OKE, you don't just deploy OKE and let your application run. Typically, most users would require some kind of additional add-ons, like they would expose the application to an ingress controller. Some of the popular ones include the Ingress Nginx, that's the community version, or Traffic. For monitoring, there's Prometheus and Thanos and Grafana for visualization. Logging, Elk has been quite popular, but now with FluentD and FluentD to ship the logs, OpenSearch is getting very popular as well, especially with the availability of the OpenSearch service. For certificate management, Cert Manager works really well, and especially if you're going to be using something like Let's Encrypt. To retrieve secrets, I mentioned earlier, you can use the external secrets operator. You can run other Oracle software like WebLogic, Coherence, MySQL, and the Oracle database on Kubernetes as well. These are all available and provisioned through various Kubernetes operators. All the operators for these are being developed in the open source on Oracle's GitHub. You can join and contribute and help us make them better. For the purpose of CI/CD, if you are not going to be using DevOps, a lot of users particularly like Argo. There's also an implementation integration for Spinnaker as well. Jenkins is still very popular, and Flux lately seems to be getting a lot of attention. Service mesh, yeah, Istio and Linkerd are very popular, and OCI has released its own service mesh recently as well. For the purpose of networking, especially for if you're going to be using network policy, Calico is well tested and well proven. Recently, we've published an article of how to make Cilia work as well, and I talk about how to use external DNS as well. In terms of security, Falco works very well. We've talked about streaming. However, if you want to run your own kind of Kafka cluster, you can do so using Streamzy inside your own cluster as well. Finally, for storage, you can use Longhorn and Rook. We've tested both of them, and they work relatively well. Governance OPA Gatekeeper is really nice, and we've got users who are using Kubeflow for the purpose of machine learning. And lastly, for performance testing, Locus works pretty well as well in scale. I've recently published an article on using Locus for the purpose of performance testing. Now, deploying all of these for one application can be quite tedious and time-consuming. And this is where Verrazano as an enterprise container platform is particularly useful. Verrazano is open source and being actively developed by Oracle, and wherever you have, it can run on private cloud, public cloud, or multi-cloud at the same time, as long as you have a Kubernetes cluster, including OKE, but not limited to. You can have others in external cloud or on-premise as well. You can run Verrazano. It uses a number of well-proven community projects like Prometheus, Grafana, OpenSearch, FluentD, Istio for Service Mesh, and we also add a number of open source controllers as well, especially for the application modeling. We handle the integration, the versioning, the compatibility. We make sure that the images are to the extent that we know they don't have vulnerabilities. And there's also support for if you're writing your microservices for various framework like Spring Boot, Micronaut, and Helidon as well. Verrazano is meant to be day one and day two operation ready, as well as multi-cluster, multi-cloud, and hybrid. It provides simplified tooling, especially for WebLogic and coherence, to bring the cloud native to your existing J2E applications, and migrate your J2E applications to the cloud or to Kubernetes if you want, and eventually evolve your application to use microservices at your own pace rather than rip and replacing it. To finish, I want to give a shout to the OK module for Terraform. So it's open source, it's community driven. A lot of these features that we've mentioned, we implement them in secure, sensible, and flexible default. It's reusable and extensible, which you can build on top of it. We accept contributions from the community. We particularly love a challenge. You can access it on this GitHub page. Please join us and help us make it better. Thank you very much for your time, and enjoy Oracle CloudWorld.